And then I hadn't seen any calculations with this formula, but recently they threw one on there. So let's look at one of these calculations. An oscillator has an initial amplitude, so our x naught is 0.180 meters, right? A mass of 0.105, and a frequency, that's its resonant frequency, of 5.20 hertz, okay? What is its initial stored energy? Okay, so we got to use this formula here, right? Okay. Notice that, let's see, our omega is 2 pi over t, right? Well, t is 1 over f, right? Isn't it? Or something like that, right? So isn't omega just 2 pi times f? Ooh, it is. That's the actual frequency, right? So the difference between, this is angular frequency, this is frequency, I don't know what it's called, right? Okay, and the difference between them is 2 pi, right? So it's like the difference between rotations per second, which is like frequency, and radians per second in rotational motion. Okay, so we can calculate the initial stored energy, right? Let's do that, right? So our E total initial, can I do that? Is 1/2 times 0.105. That's the mass, right? Omega is just 2 pi f, right? So 2 pi times 5.2. And that whole thing's squared, right? Times 0.18 squared. This is our initial stored energy. So let's do this. I can do this. 0.5 times 0.105 times parentheses 2 pi times 5.2 squared times 0.18 squared. So many things to do. I'm getting 1.8158 joules, right? So roughly 1.82 joules. So that's the answer to the first question. What's our initial stored energy? Now let's use this, we use our fancy formula there, okay? So what is the Q value? So Q is 2 pi, the resonant frequency is 5.2. Okay. Notice that this hertz is 1 over seconds. Okay. And then energy stored is 1.8158 joules. And then they're saying that it loses power at a rate of 0.135. So this is millowatts, right? Okay, so power loss is 0.135 watts, or 0.135 joules per second. Okay, so I'm going to put in 0.135 joules per second. Now, let's look at the units here. Joules will cancel joules, right? And 1 over seconds in the numerator will cancel 1 over seconds in the denominator. And again, we'll have a unitless Q. We'll have a unitless Q. All right, so 2 pi times 5.2 times the answer I just got, that 1.8158. Okay, divided by 0.135. I'm getting 439.5, right? It's really 0.46, right? So 439 is our Q. Doesn't have any units, and it's vibrating at. That's about how many times it'll vibrate, right? So this is, let's see, let's divide that by 5.2. It's going to vibrate for about 84 seconds before it stops, right? Because this is how many cycles it'll go through, right? So in about a minute and a half, it'll stop ringing. So this is, I don't know, a fairly resonant thing, right? All right,